Bally Black Jack. Original battery. Should probably pull that right off. And there is some corrosion here. Wiggle this thing off. There we go. Yeah, there's definitely some corrosion. So what I do is I pull this guy, power connector, and then we'll go over here, we'll turn it on, and we'll check the voltages on the solenoid driver board first before we get going. Power on, see what we got for 5 volts. 5 volts is nice and strong. That's at TP1 up here. Now I'm going to go to TP3. See, we got a slight difference. We've got to fix that up with a jumper on there. Let's check the high voltage up here, and we got 170 volts. That's great too. So the voltage looks good. Let's see, let's plug the MPU back in. You can see I took a wire brush. You can see the extension of the corrosion. It goes all the way up the ground plane, all the way around, and all the way up to about here. So it's pretty bad. I don't know if this is going to survive. Watch the LED, it'll flicker, but nothing more. Here we go. 1, 2, 3, on. See the flicker? Try it again. Just a flicker. Nothing more. So that means it is running the code out of the 6800 processor, but it's not addressing everything in the U2 and U6 ROMs. So let's take a look and see if we can figure out why. The battery was originally right here, and what likes to happen is these traces that come down here, here, and then these 4 here, they have continuity that go to the back of the board, and then it brings it over to these 2 chips. And these are the address and data lines for these 2 RAMs. This is the 6810 and this is the 5101. So what we can do is we can just test them to make sure that the battery corrosion hasn't eaten this stuff. So let's try this first one. I believe it goes up to the 6810. Somewhere around here, I believe. Yeah, see right there. Okay, and then this one, same deal. It goes to the 6810, I believe. Yep, you see we got buzz tone there too. So these 2 check out. Now what about these ones? This one's going to go over to the 5101. That one's good. And over to this one. Not getting anything on that one. Wait a minute, let's try it one more time. Oh, there we go. And then these 2 over here, which look pretty bad, I got nothing. So that one is definitely broken, and it sure looks broken. I mean, it just looks like corrosion has really gotten. And then this one, nothing either. So I believe like this far one here, I think goes over to this pin. I think this one here goes over to that pin. And what we can do is we can flip them over, and you can see that they're right here, so that these are the same traces. So yeah, you see they go over to those first 2 pins on the 5101. And what happens is the battery corrosion just eats it up, and it looks like it's eating it on this side. So what I'll do is I'll sand it up, and I'll put some straps through here and see if we can get some more flickers out of the board, or more flashes from the LED out of the board, and get it to boot further. So what I've done is I've stitched these. I sanded them so that the copper was exposed, tinted them with some solder, and then took some wire wrap, which is this really thin wire, stripped back, through the hole, bent it over on the top, bent it over on the bottom, and then soldered it to the tinted areas of the traces. So now I can, and I did it for all of them through here. Just, you know, it just makes sense to do it for all of them. You know, it just, and then, you know, now I can get buzz tone on every one of them. And then here are the ones we were missing. And also I forgot to mention this little one right here, this 5th one. That one goes somewhere on the 5101 too, yeah, right there. So now all those are stitched through. The other thing I did is I modified the board a little bit to take a single EEPROM. This is a 2732 instead of using the U2 and the U6. So I got a 2732 for Blackjack. And you have to do some cuts and jumpers to the to here, and these have been documented elsewhere. I don't think, you know, we really need to go through them here. So there's a couple cuts and jumpers here, and then on the back of the board, you can see this is where I did my my stitching. But on the back of the board, you have to do a cut and a jump right, I don't know if you can see it, but there's a little wire wrap wire right there. So now we're ready to put it back in the game and see if we get any more LED flashes. After I did my my trace repairs, I used a little clear nail polish and went over the areas when I was all done. This just helps prevent corrosion from returning, because the clear nail polish, which is just clear lacquer, will keep the air out, and it really will help. It's not going to save this board. I mean, there's just a ton of corrosion on it. The thing needs to be bead blasted and the sockets replaced, but I think in the short run it probably could last a few years without doing any more work to it. Okay, board mounted in the game. Let's watch that LED. Flicker, 1, 2, 3, 4, 5, 6. Ah, 6 flashes. We need a 7th. So the 7th flash is usually missing for a couple reasons. It could be that the solenoid fuse, 43 volts over here, is blown. That's typically the problem. Or it could be a problem, this resistor and this resistor over here in this little area of the circuit, they like to go open. Matter of fact, you can see some of them look a little scorched. Any one, this one, that one, or that one, any of those could be bad, and those are easy to check and replace. But I'll start with the fuses, obviously, first. That's the easiest thing. So I have the fuse removed for the solenoid voltage, and we'll just test it, and yeah, indeed, there's nothing there. So what we can do, though, is while we have the game, we're working on this, we can check the other voltages, though, just for fun. Put this right here as your ground. The first one is going to be your general illumination, or CPU controlled illumination, so we get 6 volts there. The second one is going to be the high voltage for the score displays. Should be about 250 or so. Oops, get our meter set up high. Yep, 250. The next one is going to be 15 volts for the that ultimately gets turned to 12 volts and 5 volts. That goes up to the solenoid driver board. The next one is an AC voltage. That's the GI, and you can see that's 6 volts, so that's good. And then the last one, of course, is for the coil power, which is the fuse that's blown, missing, and we get nothing. So we need to put a new fuse in. Figure while we're messing around with this thing, we should do some repinning. You can see some burns here for the lighting, but you can also see that somebody's taken the infamous wire that I think is like pin 8 on J3 here. That takes the 15 volts up to the solenoid driver board. Convert to 5. That pin always burns. You can see by the connector how it's burnt. We'll repin that correctly so it isn't soldered onto here, and get this all straightened out. I removed the whole transformer assembly. Wire brushed the male pins. They probably should be replaced, but they're actually not bad. They cleaned up pretty good. On the back side of the board, I found these are the connector pin solder points. I found a number of cracked solder joints, so what I did is I resoldered any that looked visibly damaged. There's some jumper modifications you can do here too, but I actually think we're all right here. I'm feeling pretty good about this board. It's in good shape. And I'll put it all back together, and then on the connectors, like this is the big J3 connector. Anything with a big fat wire gets a new trifurcon connector pin. Obviously the little orange wire we've now located correctly onto this. This is the 15 volts, goes up the solenoid driver board. This is that GI and CPU control lighting pin. All these pins will get replaced trifurcons. This is the input transformer plug. Usually you don't have to mess with this. There's not a lot of high current draw coming in on this, so usually the stock pins are just fine. Solenoid driver board, this is the first revision. Does not have the high voltage fuse there. I like to usually replace this cap with a new one. It's a good idea. I haven't done it just yet on this, but I have done the modifications on the back. Tie TP1 and TP3 together. These are the two 5-volt test points. This is the 5-volt filter cap we just referenced, C5. I always tie it to master ground. And you can also do the high voltage cap for the displays and tie that to ground by running the jumper across there. Check all the solder points. Make sure you don't have any cracked solder joints. This one had a few. I had to resolder. Okay, so that's the solenoid driver board. That's taken care of. Then we got to come up here. This is the input pin. There's a little thin orange wire, the same thin orange wire that we rectified down here. we've got to replace the pin up here. This is a 0.1 inch wire. It's harder to deal with just because it's smaller, but it definitely needs to be replaced. So when replacing this pin, you can see how small it is. It doesn't come in trifurcon variety. So what I do is I strip back the wire, you know, 1/8 of an inch, and then I tin it with a little solder and the soldering iron. Then I crimp the pin on, get it nice and crimped on, and then I heat up the pin to melt the tin solder from the wire onto the pin. I do not add more solder. And then just slip it back into the housing right here by my middle finger. So we've done all our work on our rectifier board, done all our work on the solenoid driver board. That's our powertrain. Now before I boot up, always remove the power connector from the CPU board or the MPU board. And we turn this thing on and check voltages. The reason why I remove that connector is just in case you made a mistake. You don't blow everything up. So let's go over here, check this TP3, and we get 5.1, perfect. Up here TP1, 5.1. Up here at the very top test point, 15 volts, perfect. And we can check the high voltage just for fun, and it's 171 volts. So we're all good. Turn it off, put the connector back on, and boot up. So I have my circuit breaker fuse set up in there, and which is just a 5 amp circuit breaker with a fuse tagged soldered in there, so I can just put it in there. That way I don't keep blowing fuses. I can work on the game if there's a short or something. I'll keep replacing fuses. And let's watch our LED flashes. 1, 2, 3, 4, 5, 6, 7. Okay, so that's good. Game comes up now. Alright, so we've got score displays. We've got a couple that are out. We got this one that's flickering. This one doesn't seem to work at all. Maybe, oh look, it does work. It's got cracked solder joints. When I wiggled, put pressure on this thing here. Look at this, somebody put that in there. That's funny. Now I just want to deal with the score displays. We had a couple issues where they were flickering. That's almost always cracked solder joints on these connectors back here. So I'm going to pull each one out and resolder those pins right now. The number one cause of the flickering is cracked solder joints. Here I can see it. This pin's cracked, that pin's cracked, that pin's cracked, that pin's cracked. This one is starting, that one is starting, but these two definitely are. So this is really common, especially on the end pins of these male connectors, because that's the pressure point. When you put it on a connector or remove it, it also tends to be the pins that traverse the highest amount of current, so it always seems like the end pins are the ones that crack. I'll resolder those, and that should fix all the flickering on the score displays. That's just for fun. Let's start a game. Listen, one of the 4 chimes is not working, and it would be the 100 chime. See, as we hit the so we hit the 500, I'm not getting any noise. I'm getting the score, but I'm not getting any noise. Okay, so that's the 10. That's working. This here, I don't know what that one is. That's probably the 1000. But yeah, we're missing. Yeah, there's the 1000. So we're missing the 100-point chime. But other than that, it seems to be working good. Just fix the chime and we'll be all set. Inside the cabinet are the 4 chime coils, 3 on this bank and 1 on this one. You can see that this middle one, this is the 100, is melted. It's pretty common to see this happen. So we'll need a new coil, and then I suspect that up on the driver board in the back box, there's a locked-on shorted tip transistor that drives that guy. Okay, so I have the new coil installed. I haven't done anything about the solenoid driver board driving transistor. That's no doubt the reason why that locked on and shorted, causing this coil to lock on, and then that's what blew the solenoid fuse on the rectifier board, transformer rectifier board. That's probably what happened. But let's just, as a double check. Oh, remember when you solder the wires, the daisy chain green wires are the power. They always go to the banded side of the coil lug. So the diode with the band, that's the lug that gets the green power wires. Okay, and you can always compare them to this guy, just if you get confused. I'm going to turn it on. If this coil locks on, it'll hit that chime and stay on. If it doesn't, maybe we'll be okay, but let's give it a whirl. Look, it locked on. So as soon as I turned it on, it went on. So that means that the up on the driver board behind the back box. We're going to have to repair a driving transistor up there. New Q5 at tip 102. Over here on the rectifier board, I removed my circuit breaker fuse and put a genuine 5 amp fuse in as required. Now we'll turn the game on. Hopefully we won't hear that chime ring when I hit the power switch. So here we go, 2, 3, 1. Oh good, that's a good sign. Close this guy up and listen to the song. There you go, I heard all the chime noises. Okay, so now let's start a game. Hear the call to post with all the noises. And now we can see, look, we got our 100 points is now working. Our tens are working, our thousands are working, but our hundreds are working. So now all our chime sounds are working. So where does this leave us? This board, now let me power this thing off, is still in pretty poor shape. The corrosion is going to come back to haunt us. Not so much the corrosion, well, in addition to the corrosion, the sockets. These are the closed frame auget sockets. These things are crap. I mean, they're just after 30 years, they're beat. They don't pass my test. Look at my finger test. Look, I can pull this chip out with just my finger. I don't want to be able to do that, so these sockets are going to have to be replaced. 1, 2, 3, 4, 5, 6. And all the battery corrosion is going to have to be bead blasted to make this board really reliable. I've kind of got a decision here if I want to just run the game as is and see how long it lasts, or if I just want to go with the total reliability and just replace the board. I'll kind of leave that up to the owner and see what they say. But other than that, the game is all working, and we're ready to fly.